Basic concepts of blockchain. Here we are going to learn concepts like cryptographic hash function, timestamp, block header, Merkle root, peer-to-peer network. Let's see cryptographic hash function. A cryptographic hash function is a hash function which takes as input or message of any length and going to return a fixed size alphanumerical string which is called hash value. Sometimes it is also known as message digest or digital fingerprint or digest or checksum. Blockchain uses SHA-256, which abbreviated as Secure Hash Algorithm 256, using for hashing algorithm to convert text of any length into a fixed size string of 256 bits. Properties of cryptographic hash function. Deterministics. The same message always result in the same hash. Quick to compute. Hash value computes very quickly. Infeasibility. Generated message that provided hash value and reverse process also achieved, which means hash value to message. Avalanche effect. A small change to a message should change the hash value. Let's see the basic demo how the hash function is going to compute. This is basic application, helps to understand how to generate hash. Here we are supplying a input data called welcome. When I typing each letter in a welcome like W, produces fixed hash. In below you can observe the hash. Next, when I typing a letter called E, combination of W and E produces hash. Similarly, when I typing a welcome, it produces welcome hash here. In below clearly we can see hash of welcome is 28064 so on up to 2D02, which gives 64-bit output. This algorithm is designed with the help of SHA-256. Timestamp. Blockchain uses timestamp to know when the block is mined and when it's added in a blockchain. It's defined as a timestamp is a sequence of character or encoded information identifying when a certain event occurs, usually giving date and time of day, accurate seconds, event count small milliseconds fraction also. Computer uses Unix timestamp or epoch conversion which follows elapsed rule. Example, let's take a date of 17th March 1991 at 2:43 AM. Then timestamp compute as 6691777780. How it's calculated? Let's see the explanation. Unix timestamp counts millisecond since January 1st, 1917 UTC. How to calculate epoch Unix timestamp? First, take the difference between 17 March 1991 2:43 AM to 1st Jan 1970, which means it's calculate the past time is 1006 weeks, 3 days, 2 hours, 43 minutes, 0 seconds. Which means total weeks are 1106.444742. Total days are 7745.11319. Total hours are 185,882.7167. Total minutes are 111,52963. Total seconds are 669177780. It's difficult to remember and calculate Unix timestamp. Here I will show you shortcut to calculate timestamp in two ways. First thing is using Excel. Now I am taking a date 17 March 1991 including time 2:43 AM in C2 row, and in D2 I am written a formula that subtracts 17th March 1991 minus epoch timestamp, that is Jan 1st 1970, and multiplying seconds 86,400 is equal to 1 day, that is 24 hours 60 minutes 60 seconds, which resolves 669177780. Second way is use epoch conversion application. Here I am entering 669177780 in text field, which gives exactly date and time while pressing this button. Here you can see Sunday, March 17, 1991, 2:43 am. What is block? A blockchain is a growing list of records called block that are linked together using cryptography. First block in blockchain called as Genesis block, which represent as block 0. What is Genesis block? A Genesis block had hardcore into software of application, which is written in the form of JSON format, contain configuration setup like blockchain version called home state, difficult level, mining fee, address allocation, etc. Each block contains a cryptography hash of previous block, a timestamp, and transaction data called Merkle tree. In block 1, previous address is pointing to Genesis block. Nonce. In cryptography, a nonce is an arbitrary number that may only be used once. It is often a random or pseudo-random number issued in an authentication protocol to ensure that old communication cannot be reused in replay attack. Merkle tree is a tree in which every non-leaf node is labeled with a hash of label or value of a child node, allows efficient and secure verification. We will see in detail in the next topic. Next hash, which holds next successive block called 2. Timestamp, update unique time when the block is added in the chain. In block 2, also having similar format like block 1 called previous hash, nonce, Merkle root, next hash, and timestamp. Let's see real-time block in a Bitcoin blockchain. Here in search, just type 0 and enter. This page get loaded with Genesis block called block 0. We can observe that the first block is added at 2009 1st March. We can observe hash of this block, difficulty level is 1, Merkle root, nonce, and fees of that block, and the first transaction is 50 BTC. Next topic is Merkle root. A Merkle root is a simplest mathematical way to verify data on a Merkle tree. A Merkle tree are used in cryptocurrency to make sure data block passed between peer-to-peer network. Merkle tree is similar to binary tree format. Let's assume there is a H transaction appear in a peer-to-peer network called T1, T2, T3, T4, T5, T6, T7, and T8. Now, the hash of T1 is named as H1, the hash of T2 named as H2, the hash of T3 named as H3, the hash of T4 named as H4, the hash of T5 named as H5, the hash of T6 named as H6, the hash of T7 named as H7, the hash of T8 named as H8. Now, hash of H1 and H2 combined together and making one more hash called H12. Again, hash of H3 and H4 combined together and making one more hash called H34. Again, hash of H5 and H6 combined together and making one more hash called H56. The hash of H7 and H8 combined together and making one more hash called H78. Which means second round of hashing is happened. We have to do hashing until we reach single hashing similar to divide and conquer method. Again, hash of h12 and h34 combined and performing hashing which result h1234. Similarly, the hash of h56 and h78 combines and performing hash which result hash of h5678. Like that, we have to do hash of h1234, h5678 and combines results h1234, 5678 called Merkle root. Note, suppose above example having event transaction we done with pairing with neighbor transaction. Assume that there is an odd transaction. Then how can you solve? Simple. In this case, we have to take one more transaction called last transaction. Example, if we have 7 transactions, then take 7 transactions as 2 times, like T7 and T7, which results event hash called H77. Our next topic is peer-to-peer network. A peer-to-peer network is a network in which all the computers are linked together with equal privilege and responsibility for processing the data. A peer-to-peer architecture consisting of a decentralized network of peers. Each node acts as both client and servers. Let's look at a small example. In a network, 4 computers are connected with each other, namely node 1, node 2, node 3 and node 4. Node 1 is connected to node 2, node 2 connected to node 3, node 3 is connected to node 4 and node 4 also connected to node 1. It's making a circular loop again. Node 1 again connected to node 3 and node 3 also connected to node 1. Now node 4 also connected to node 2 and node 2 connected to node 4. This type of network connection known as peer-to-peer network. If any transaction initiated by user, then transaction goes into all nodes connected in a network. Thank you. In next video, we are going to see interesting topic is how to get free bitcoins and how to become miner and proof of work.